I'm just going to drag this.
So this is Thursday, April 15th, and we are we're going to work on protein synthesis today, which can be kind of a tricky topic. So we've got a lot of things for you to do along with us. You need to really be participating right along with us. We give you something to do. Give it a try. The pair deck that we're going to do today, we're going to give you a little break for that. All you got to do is log in and participate. Okay? And then there is a slide deck that I want you to do while you're here in class that is almost identical to the pair deck. So there is no excuse for getting anything wrong on this. It's a lab grade. So you can go into that once we've done the pair deck, and then you'll feel great. Okay.
All right.
One last thing I want to tell you is look at the bottom of the slide. What do you see?
What do we see?
In big, bright blue next to me in the unicorn. What's written down there?
Next Thursday. Yeah.
Ariel, what's next? What do we have looking up here? What's next Thursday? Yeah, what's it say up there? Huh?
It's on your own screen.
Do you not have your screen up for the BBCU? What do you have open? What is that there? Is that a pair deck? Oh, I appreciate you getting the pair deck open and ready. Thank you. Unit test next Thursday.
Unit test next Thursday on protein synthesis. We'll have one more day of learning on Tuesday, and then the unit test is next Thursday. And it'll be an e-cart multiple choice, just like always. I just want you to be aware of that. Now, Mr. Bouchard is going to go over a first exposure to protein synthesis with you. He's got a video that he likes.
I do like this video.
Let him go.
Miss Murdoch does not like, full disclosure, I'm more of a fan of it. I think she finds it a little corny, and the music probably kills her. Because now, let me fully disclosure on this sounds. It is not the greatest. It is a bunch of 70s weird music. Uh-oh. What just happened? It just went blank. Oh. Yeah, that's what happened. Sorry, I lost the cord for a second. Man down. Man down. All right, so let me first go ahead, and I'm going to share. Oh, well, it's already sharing the whole thing, so I can just click on this one. Is this it, Ms. Murdoch? Did it open up in YouTube? Is that what it did?
That's my video. If you want to use that, that's awesome, but that's not yours.
Oh. Do we have it already open, or do I need to open it? Give me a second, guys.
You got to go to the hardware. There you go. Open up that.
That's it. I knew.
External DVD player. Hardware and access it.
I am just going to stop sharing everything for a moment.
Like always, guys, sorry for the technical difficulties.
I apologize for that. It is what it is. I'll share this so you can see this while it loads up. Okay. Okay. So here we go. Again, if you didn't notice, I got a little jealous of Miss Murdoch and her dancing unicorn. So I had to find myself a dinosaur with hearts. Oh yeah, if you look on the opening screen, the dinosaur. Thank you, Pedro. Thank you. So Miss Murdoch will see it. She'll laugh later, and then she'll put it on the next one. I was like, I couldn't have the winter one anymore. It is a Stegosaurus. You're right. Okay, let me go ahead. Stop sharing this. I'm going to share one thing. Chrome tab. No, not a Chrome tab. Application window. Yes. Share this. And
can you turn a burger into hair? I do it every day inside your cells. My DNA.
Pedro's like, oh my God.
Inside you. It breaks down into amino acids. I take these little amino acids and build them up into useful proteins. Like what's in your hair. When it comes to building protein, I run the show.
Sydney,
I do have helpers.
stop with the
Transfer
comments.
RNA. They tow amino acids. And I have a messenger working for me. Messenger RNA. Protein building starts when I split.
Oh, shoot. I hit the wrong pause.
I'm going to put you guys together and make you my messenger. Places, everyone.
All right, really quick. Sorry, I'm just stopping a little bit while we talk. This right, sorry, I tried to stop earlier. That thing was called where they split it. What is this? Either here, somebody in class, tell me, what is this whole row attached to the green guy? What is that row? What is that right there? This whole row is your what? It's in your cells, in your nucleuses. It's responsible for everything about you. DNA, yes. DNA, who said that? Gibson? Very good. This is your DNA. So what has happened so far is your DNA has split. Notice, only a portion of the DNA has split. Sorry, Ms. Murdoch, I just wanted to stop while I talk about this. Only a portion of this has split. And the reason only a portion is because you're not copying the whole DNA. I want you to get that understanding now. We are not copying the whole DNA strand. We are only going to copy a portion of it. Think of your DNA as your cookbook. Your whole DNA is a cookbook for you. You only need one recipe for making a protein, a certain protein your body needs. So it's only going to get that portion of the DNA. So the whole thing is not split. And what we're making right now is the mRNA. It'll go back at the end and review it all at once. I just want to stop a little while we talk now.
As long as you do things my way, we'll get along just fine. Uh-oh, you fellas are out of place. That's better. You've got to be in the right order. Perfect. Now you fellas are a code. You're a protein building code. I'm stranded here in the nucleus, so you fellas have got to go out there in the cell for me and make protein. My messenger.
So, what has happened so far? DNA cannot leave the nucleus. DNA is huge, so it can't leave the nucleus. You can't take the whole cookbook out. All you can take is a recipe. So what has happened right now, it's the first stage, is called transcription. They've made this strand right here, which is called mRNA. And all mRNA is think of it as one recipe out of the cookbook. It's only one recipe, not the whole cookbook. And this one mRNA strand, in comparison to DNA, is small. So if it's smaller, what do you think? Can it leave the nucleus? Anybody on chat or in person? Yes, Pedro, yes. The mRNA can leave the nucleus. It's only a portion of it. It's smaller, and it's taking that code, and it's going to leave the nucleus.
So there are big differences between RNA and DNA. You guys have already been learning those differences. Now you're going to see exactly how those differences are used by the cell. During protein synthesis, DNA is like a giant library of information. It has to stay in the nucleus. It doesn't move. It's like a big library, right? RNA is like taking out a book from that library. So you're taking out a single transcript from one gene to make a single protein. That's what the RNA does. Single-stranded, move out of the nucleus into the cytoplasm. So keep watching what we try to show you.
And I'm going to keep stopping a little bit. I'm sorry, guys, but I think it's very important.
It's for the ribosome, where protein is built and waits for the amino acids. Meanwhile, transfer RNA picks up amino acids. Each transfer RNA goes after a specific amino acid, then tows it to the ribosome. In the ribosome, messenger RNA attracts a specific transfer RNA. The transfer RNA links to the messenger. The ribosome slides every...
All right, really quick. Evan, you're a smart man. You're right here, so I'm just going to call on you. Sorry. Where is this occurring? What organelle? Yes, in the ribosomes. Ribosomes. So in the ribosomes is where this is occurring. So right now you have your mRNA in there. This tow truck thing is tRNA. And what tRNA is doing is bringing free-floating amino acids, certain ones that it picks up. Notice, this red guy only picked up a certain type. Hey, Ariel, I need you facing up here because you're not watching anything there. Heads down, don't do it. So somebody tell me, either in person or on there, tRNA, where do you get these free-floating amino acids that your body's using? Where are you going to get these from? How are you going to get these in your body? Anybody? No? How do you get these things you need in your body? So simple. Yeah. Food! Yes! Exactly. Thank you, Ariel. Yeah, that's all. It was so simple. You're like, it can't be that easy, right? Yeah, it really is. So your body breaks down all this food and stuff you have because within your body, when you eat those cells, they have amino acids and stuff in them. Your body breaks them down and uses them. Your body is very good at using everything it can. So it breaks down whatever food, or if you take a vitamin, I take a vitamin every morning. So my body can make sure it has some amino acids in it. So all the food you have, according to the FDA, have certain amino acids in it because they don't count on us to always eat properly. So even in your potato chips, if anybody like potato chips, I love sour cream. I love, what are those, oil and vinegar? Barbecue potato chip. Look on the backs of them. You'll see they have amino acids and certain things in them that your body needs. Now, it doesn't always need all the other stuff that's in it, but what the FDA does is make sure they put certain things in it that your body will use. So there are amino acids and stuff in there, but if you look on the thing, there's also a bunch of other things that your body does not need. And that's why I get very chubby when I eat all my chips. The salt and vinegar. Is it salt and vinegar? Is that the ones I'm trying to think?
I love salt and vinegar.
Oh, salt.
Well, they really want amino acids when you eat stuff like
Salad.
or peanut butter or tofu or steak or hamburger. That has a lot of amino acids.
Ooh. Sour cream and onion are another good potato chip. I like sour cream and onion dip with my potato chips. All right, you're getting me off topic. Yeah, way to go, Pedro. Got me off topic talking about sour cream and onion chips. Good job.
And the next transfer RNA moves in and shoves its neighbor aside. The amino acid left behind connects to the one beside it.
I'm going to stop in a second.
The process continues. A chain of amino acids is being built. When the
So what's happening after, sorry guys, I'm just stopping this the first time. We need to talk about it because this is how I'm going to present most of it now. These is forming a chain of amino acids. Notice the first one came in and then connected to the second one. Those guys don't hang around. They're not like, hey, let's do some hanging out RNAs here. Those RNAs go back out and find other free-floating ones to bring them back in. They have a job. They don't just sit there and sit around the water cooler and be like, oh, look at that nice protein we're building right there. Yeah, that's pretty good. Yeah, I'm glad we brought that in. No. So tRNAs will move out after they brought in a protein.
chain is complete, it leaves the ribosome and changes into a useful protein that goes to work in your body. This one will become hair. So now you know how your hair started out as a burger.
I'll be quiet real quick.
I'm going to put this cell in high gear.
Here's where it gets really great. What happened? It's just okay. Well, that's fine. I think something happened with the disk. All right, that's okay. So we're gonna just stop that right now, anyways. Yeah. So the second stage, as I was talking about, is called translation. So transcription was the first stage, and when they're in the ribosome, you're then translating that code into a protein. That's how I think of it. You scribble down transcription, scribble down the code, then you take it and you translate it in the ribosome into a protein. That's the best way I think to do it. Okay, so my lovelies online and in person. Do we have the Pear Deck open? We do. There we go. I didn't know. Well,